There are an estimated this many individual viruses on Earth. Luckily, there are only a little over 1,000 virus strains known to infect humans, the majority of which come from other animals. They're part of a group called zoonotic diseases, caused by bacteria, viruses, parasites, or fungi. And the one we're all focusing on now is the virus that causes COVID-19. And new ones can emerge at any time. Here's what needs to happen for a virus to jump from animals to humans. As a pathogen, the virus's goal is to infect its host and replicate, because it can't do that on its own. Let's say this pig is the original host of a virus. He and his buddies form a reservoir, a specific population of animals of the same species that naturally host a pathogen.
So there are millions of viruses out there infecting animals, literally millions. I mean, the more we look, the more we find. And most of those viruses don't infect, other animals. They have a restricted host range.
Most of the time, the virus doesn't affect its original host, or only mildly affects it. So, what's it doing in there? Suppose that this pig hosts a virus that primarily infects the gut. Viruses tend to attack different parts of the body, depending on whether they can bind to these guys. Receptors are proteins found along the outside of a cell, used to communicate with the rest of the body. But viruses can latch on too. Cells in a respiratory system may have different receptors than cells in a digestive tract. A virus does its thing by latching onto a host cell, entering it or injecting bits of itself into it, and then hijacking it. It forces the cell to make copies of the virus, all of which will go on to hijack other host cells. This will usually kill the host cell. And if enough of the host cells are infected and make more of the virus, the host will contract an infection, which, if the body can't fight it off or fights too hard, could lead to severe disease or death. In reservoirs, however, the species has likely evolved a resistance to the virus over many generations. This allows a sort of equilibrium. The immune system controls the infection without killing the virus off completely. If the virus jumps, though, a new host won't have that same or any immunity. That might sound scary because, truthfully, you are constantly being exposed to viruses, but only a very small number succeed at infecting a new host species. It's called spillover, and there are a series of barriers that a virus must navigate for that to happen. If it's held up by even one of these, it can be stopped in its tracks. Simplified, they represent two things. Can the virus get to the new host cells, and can it bind and enter them? The more infected pigs there are in one space, and the closer they are to people, generally the more chance of spillover. But the likelihood also has to do with how the humans are interacting with them. Animal viruses are usually transmitted to people in a few ways: contact with excretions, slaughter, bites, contact with tissues, or through an intermediate species like mosquitoes or ticks. So places like farms and slaughterhouses and even petting zoos, where people come in close contact with animals, have an increased risk of spillover. Proximity alone isn't enough, though. Some of it can be genetic for humans. There's a huge list of genes that have been associated with different risks of infections, some genes offering resistance to certain infections and others increasing risk. Beyond genes, the virus has to get through the body's innate immune responses.
So there's two types of immune responses. One is the so-called adaptive immune responses. So those are antibodies and T cells, and they generally get stimulated after the infection has already occurred. The innate responses are the ones that are already present inside the cell that make a cell or a host, resistant to the virus.
Unlike an adaptive response, an innate one can attempt to fight off any pathogen rather than a specific one. Mucous membranes, stomach acid, skin, sentinel cells, and even just a lack of the right receptors can stop a virus from infecting a person. So this is when mutations are really important. A successful spillover usually doesn't happen with the original virus.
They have to gain some mutations that allow them to replicate most efficiently, allow them to overcome those host barriers,
A virus that infects the digestive system of the pig might attack respiratory cells in humans. It depends on what receptor the virus is suited for or mutates to be suited for. Once inside the new host cell, an infection will only be successful if the virus can replicate. Typically, infected cells will release interferons, proteins that stop the virus from replicating within the cell and in nearby cells, which contain the infection and stop it from spreading to new cells.